Yes, everything is good to start the class, right? Just respond in the polls whether my voice is clearly audible to you all or not, and my screen is visible to you all or not. Yes, I think it's clear. Everyone, everything is good. We should start, huh? We don't have time. Chalo, ठीक है. This is the second lecture. Okay. So this is the second lecture of PNC, that is permutation and combination. In this class, we are going to cover what are the concepts we need to cover. That is, first we'll see combination, then we'll learn how to form group, then we'll study circular permutation also. You know, these three things we will cover in this session. Okay, so let's understand what is combination. Okay, if I'll ask you, in your screen you can see you have an apple, an orange, and one banana. And if I'll ask you to, in how many ways do you choose 2 fruits out of 3 fruits? So what should be your answer? Tell me. Let me know in the chat box, everyone. What is your answer? So no need to go through the definition of permutation, combination, nothing else. Just usually do what is in how many ways do you choose 2 fruits out of 3 fruits? Like this way we can choose na. We'll choose apple first with an orange. We can choose apple. We can choose banana. Then we can choose banana with apple, or banana with orange. Then we'll choose orange with apple, orange with banana, or what are other? We can choose first orange, then banana. No, sorry, apple. Then first banana, then apple. Then first apple, then banana. Then we can choose also first orange, then banana. Then we can choose first apple, then orange. Then we can choose first banana, then orange. Apple, orange, apple, banana, banana, apple. So these are the pair. These are the 2 fruits we can choose from out of 3 fruits, right? So can you tell me, if you are choosing 1 apple and 1 orange, and also we are choosing 1 orange and 1 apple, they are same or they are different? Let me know in the chat box, everyone. These 2 pairs are same or different? You are having 1 apple. What I am saying, you are having 1 apple, 1 orange, and again I am saying you are having 1 orange and 1 apple. Is there any difference between these 2 pairs? Actually, they are same. Actually, they are same. So how many times we are duplicating the situation? See, apple, banana, banana, apple. These 2. Okay? Banana, apple, apple, banana. ये तो हो गया. Oh, we have written already, huh? ठीक है. So how many times it will be duplicating? See here, apple, orange, orange, apple, and orange apple also here. So thrice it is actually duplicating. So the right thing is, so when we are choosing some objects, or we are choosing or selecting, ठीक है? then we'll choose then the order is not important. Order is not important. Okay? When we are choosing or selecting, in that situation, order is not important. But when we are arranging some objects, in case of permutation, order is important. है ना? In case of permutation, order is important. Apple seat besides apple seat left to orange, and orange seat left to apple. So these are two different cases we are counting in case of permutation. But when we are talking about choosing, selecting, or making groups, in those situations, order is important. In that is actually combination. When you are using these two words, choosing or selecting, we are talking about combination. Is that clear, everyone? We are talking about combination. That means here order is not important. When you are selecting objects, the order will not be matter, right? Is it clear to everyone? Let me know in the chat box, everyone. Let me know in the chat box. Is it clear to everyone, guys? Yes? Okay. So this is actually to understand how we are using combinations and why we should use the combination, right? So let's see what is the definition of combination. Okay? So combination is each groups or selection. See here, each groups or selection which can be made by taking some or all things without considering the order of the things. Important. Without considering the order of the things in each group is called combination, right? So generally involves the problems of selection, choosing, distributed group formation, committee formation, geometrical problem, etc. So actually basically we are denoting combination by NCR, permutation by NPR, and combination as NCR. Denotes the number of combinations. This is what is the meaning of NCR? Denotes number of combination of n different things taken R at a time, where n belongs to the natural number and R belongs to whole number, and R must be less than equal to n. Okay, so what is the formula? The formula is actually NCR is equal to n factorial upon R factorial into n minus R factorial. Is that clear, everyone? Guys, is that clear? Tell me. Is that clear, everyone? Yes. So actually, in combinations, what we are doing? Can you tell me? In case of combination, what we are doing? First, see here. First, we are arranging our object. First, we are arranging our object. Then we are selecting R objects from n objects. That is actually R factorial into NCR is equal to NPR. Remember, arranging R objects, arranging R objects from out of n objects is equal to R factorial into selecting R objects out of n objects. Remember this formula only. We don't have much time to explain all these things in detail. Okay, let's see some properties of combinations here. Okay, NC0 is 1, NC1 is n, NCn is 1, and NCR is NC n minus R, and this is actually n plus 1 CR. NCR plus NCR minus 1 is actually n plus 1 CR, right? Okay. Or you can take a screenshot of this screen. One example here we have. Okay. So there are 10 points in a row. In how many ways can 4 points be selected so that no 2 of them are consecutive? Total number of remaining non-selected points is 6. So what is the answer? I am giving you 1 minute for this question. Let me know in the chat box what is the answer. Your time starts now. Everyone, what is the answer? Respond in the chat box. All of you guys, please. YouTube guys, also you can respond in the chat box also. Yes. Anyone got the answer? JNB Rajkot, JNB Warangal, JNB Pune, Akola, JNB Srikakulam. Anyone got the answer? Okay, it's time up. Time's up. Let's see what is the solution for this code. Okay. So we have 10 points in a row. Now, how many ways can 4 points be selected so that no two of them are consecutive, right? So total number of remaining non-selected points are 6, right? See here. So what I'm doing here, I'm taking those non-selected points first, and I'm placing them in a row. Okay? And in between these 6 non-selected points, we have how many space we have? That is 1, 2, 3, 4, 5, 6, 7. Remember. So total number of gaps made by these 6 points is actually 7. Yes. So if we select 4 gaps out of these 7 and put 4 points in selected gap, so then the new points will be represent 4 points so that no two of them are consecutive. That is, total number of ways of selecting 4 gaps out of 7 gaps is actually 7C4. This is the answer. Very simple. We have 7 places and we need to choose, or we need to select 4 places for 4 points. Okay. We have 7 places and we have 4 points. We need to place them in those 7 vacant places. So how many ways? We can select 4 places out of 7 places. That is, the answer is 7C4. Is that clear to everyone? Just let me know in the chat box. Is that clear? Yes. Guys, respond in the chat box. Is that clear? Sure. Let's move. Now we'll understand circular permutation. What is that? Circular permutation. The number of circular permutation of n different things taken all at a time is n minus 1 factorial. Okay? N minus 1 factorial. How it is actually happening? Can you tell me how it is happening? If we are arranging n objects out of n objects, that is in n factorial ways. So in how we can say if we are arranging n different objects in a circle or in a circular table, then the total number of ways of arranging those n objects is actually n minus 1 factorial ways. Okay. So how we can understand this concept? Suppose we have 3 persons. Okay. We have 3 persons. One is A, B, C. Okay. So they are in a row. They are in a row. Okay. So in how many ways we can arrange them? That is, the answer is very simple. That is 3 factorial. Okay. That is 3 into 2. 6 different ways we can arrange them. If they are in a circle, see, suppose this is my circle, this is my A, this is my B, and this is my C. Okay. So in how many ways we can select, we can arrange them? So first go A, B, C. This is one arrangement. Then we can say A, B, C. Then we can say B, C, A. Then we can say C, A, B. Right? Then this is one way, and also This is clockwise. If we will consider the anti-clockwise arrangement, then what will happen? ACB, CBA, and BAC, BAC. है ना? So how many ways actually we are arranging? So ABC, ABC, A up, then B, then C. ठीक है? Then ABC, BAC, no, CBA, ABC. Oh, some duplicate C is happening or not? ABC, then ACB, we are considering this, yes, ACB, then BAC, BAC, ABC, BAC, consider this BAC, we don't have BAC now, yes, BAC, ठीक है, ABC, BAC, then this is the actually in row we can arrange in this way. If we will do in the circle, so what is the order? So we need to check first A, then B, then C. ठीक है? First then B, then C, then A. Okay, this is 1, 2. Then B, A, C. ठीक है? And this is B, C, A, right? And C, A, B. ठीक है? Then C, B, A. So see here, A, C, B, A, B, C, and A, B, C, and B, C, A, B, C, A, and C, A, B. ठीक है? A, B, C, then B, we are starting from this point, A, B, C, then B, C, A, B, C, A, then C, A, B. These three arrangements are same or not? Yes. Yes, they are same or not? Yes, they are same. Why? Because after B, if you move the circle clockwise, then you can say, sir, the position of A is here. So just move the circle. You can take here. If you move this 45 degree, if you move this 45 degree, A will be coming to this place. So these three arrangements are same, and these three arrangements are same also. Right? I hope this is clear to everyone. These three arrangements are same, and these three arrangements are same also. So total in circular system, in how many ways we can arrange them? Now that is 3 factorial. So that is actually how many ways? 3 minus 1 factorial ways. Total number of arrangement will be 3 minus 1 factorial ways, that is 2 factorial. Yes, in 2 different ways. This is one arrangement and this is one arrangement. Okay, so in total 2 factorial ways, or in only 2 ways we can arrange them in a circle. But in case of linear permutation, that is in case of row, when we are arranging in row, there are 6 such arrangements. There are 6 such arrangements we can consider. But in case of circular permutation, we will consider one is anti-clockwise, another one is clockwise. These are 2 arrangements will be happen. ठीक है? Is that clear to everyone? Clear? ठीक है? Okay. Sure. So let's understand. This is the thing. If the clockwise and anti-clockwise circular permutations are considered to be same, then okay. Here in this case, what we are doing? Sorry. In this case, what we are doing? In this case, what we are doing actually, we are considering the clockwise and anti-clockwise direction. then the answer will be 2 factorial, that is n minus 1 2 factorial ways we can arrange them, right? But in case of garland, in case of garland or beads, or when suppose here you are having 1 2 3 4 5 6 beads, and you have to place these 6 beads in a bracelet. So what should be the order? So what should be the number of ways, number of arrangements will be that is n minus 1 factorial by 2. Why we are dividing 2 here? Why we are dividing 2 here? Because why we are dividing these things 2 here? Because we are considering the same situations twice. We are considering the same situations twice. Because if you'll suppose if you'll take a garland, and here you have blue ball and here you have green ball, just rotate it 360 degree, you can say, just rotate it. So this situation, this blue ball will be coming to this place and the green ball will coming to this place. But these two situations are same. That's why I am dividing here 2, because we are considering the same situation twice. That's why I am dividing 2 with the original arrangement, the total number of arrangement upon 2. Is that clear to everyone, guys? Is that clear? Why we are dividing in case of garland, or in place of when you are placed some beads in a bracelet? Also, in that case, we need to divide 2 with n minus 1 factorial. Clear? Chalo, let's move. Let's solve one question. In how many ways can we arrange 6 different flowers in a circle? Different flowers in a circle. In how many ways we can form a garland using these flowers? So answer will be very simple. Answer is very simple. The number of circular arrangements of 6 different ways flowers is 6 minus 1 factorial, right? That is 120. That is 120. Yes. Ooh. Okay. Okay. And when we form a garland by using these 6 different flowers, then the clockwise and anti-clockwise arrangements are similar. Clockwise and anti-clockwise arrangements are similar. Therefore, the number of ways of forming garland is actually 1 by 2. Matlab n minus 1 factorial by 2. That is 6 minus 1 factorial by 2. That is 60. Okay. Is that clear? So everyone clear? Everyone understand the concept of circular permutation now? Yes or no? In case of garland or bracelet, you can divide 2 with n minus 1 factorial, and when you are arranging n objects taken all at a time in a circular table, then the answer will be n minus 1 factorial. Is that clear, everyone? Okay. So let's solve another question. Okay. Here you have a concept. In how many ways can 5 boys and 5 girls be seated at a round table so that no 2 girls are together? How we can solve this question? I'm giving you 1 minute for this question also. And your time starts now. Try to solve it. Who is getting the answer? Can you please respond in the chat box? Yes. Anyone got the answer? Yes. What is the answer, guys? Anyone got the answer? Chalo, let's solve this. है ना? So, leaving one seat vacant between two boys. Five boys may be seated in 4 factorial ways. Suppose first what we are doing, we are placing first 5 boys in a circular table. Let's start. Suppose what I am doing, first I am placing 5 boys in a circular table. P1, B2, B3, B4, and B5. These are my boys seated in a circular table. And we need to sit 5 girls to be seated at a round table so that no 2 girls are together. That means in between 2 girls there must be a boy, right? There must be a boy. Okay. So what is the way? So we have how many gaps we are having here? Can you tell me? One gap. 1, 2, 3, 4, 5. So we have 5 places and we need to place 5 goals in 5 places. That is, in how many ways we can arrange them? In 5 factorial ways. Right. So first thing is 5 boys can be seated, or 5 boys can be arranged in a circular table in how many ways? So we know na n objects can be arranged in a circular table taken all at a time, that is n minus 1 factorial ways. So 5 boys can be arranged in a circular table, that is 5 minus 1 factorial ways, that is 4 factorial ways. Okay, and we need to seat those girls in between 2 boys. Okay, in how many places we have? We have 5 places and we need to arrange 5 goals in those 5 places also. That is, in how many ways we can arrange them? 5 factorial. So 4 factorial into 5 factorial will be your answer. Is that clear to everyone? 4 factorial into 5 factorial is the answer. Is that clear to everyone? Guys, please respond in the chat box. Yes. Remember, in this case, I'm sorry, actually, here I forgot to tell you. For in the first case, clockwise is not equal to anti-clockwise. Okay, but in this case, in case of garland or bracelet, we are taking clockwise and anti-clockwise directions are same. In case of garland or bracelet, but in case of circle, when we are arranging some 5 different boys in a circle, that is n minus 1 factorial, or we can say 5 minus 1 factorial, 4 factorial ways. Okay, is that clear? Yes. So this is the solution. If this solution is clear to everyone, let me know in the chat box, everyone, guys. Let me know in the chat box. Is that clear? Okay, so let's move. Okay, here you have a problem. Number of ways of dividing 10 people into into group of size 6 and 4. You know, this is the formation of groups concept we need to understand here. Formation of groups. Okay. Okay, so let's understand first the number of ways in which m plus n different things can be divided into two groups such that one of them contains m things and other has n things. Then the answer is actually m plus n factorial divided by m factorial divided into n factorial, where m is not equal to n. Right? This is the formula. Remember, formation of group. When you have m plus n different objects, and you need to divide these objects into two groups of size m and n, then the number of ways to divide into groups, that is m plus n factorial into m factorial into n factorial. Is that clear, everyone? Okay. So and suppose the simplest way is you should remember this formula. Suppose we have m plus n objects and we need to divide these into two groups of size m and n. So the number of ways will be, then the number of ways will be is actually m plus n factorial upon m factorial into n factorial. Okay, clear? Okay. Second thing is, if m minus n, it means the group are equal, and in this case the number of divisions is 2n factorial by n factorial into n factorial into n2 factorial. Okay, as in छोड़ो complicated, मैं बता रहा हूँ तुम्हें. ठीक है. So what is the way we can division of objects into groups? Okay, division of objects into groups. So first of all, if you have m plus n objects, different objects, okay, and you need to divide these into two groups. One group is of size m and another group is of size n. Then the number of ways will be m plus n factorial divided by m factorial into n factorial, where m is not equal to n. That is actually how we can choose, how we can derive this formula. Can you understand? Okay, so suppose total number of objects is m plus n, and you need to select first m objects out of m plus n objects. So that is in how many ways we can select? That is m plus n c m objects into, then how many objects you are left with if you are subtracting m objects from m plus n objects. So in total you are having n objects, and you need to select again n objects with the groups, right? So this is the way, and this, if you will simplify this, we'll get m plus n factorial divided by m factorial into n factorial. Is that clear? Okay, so second scenario, case 2, corollary 2, we can say, the number of ways of distribute m plus n distinct objects among two persons in distribute, मैं थोड़ा धीरे पढ़ा रहा हूँ, ठीक है, distribute m plus n objects among two persons in the group containing m and n objects. ठीक है. So what will be the answer? Answer ये क्या हो जाएगा? That is, the answer is actually number of ways to divide, number of ways to divide into number of groups. So what is the answer? Number of ways to divide m plus n into two groups is actually, that is in 2 factorial ways. We need to divide into two groups, na? That is 2 factorial ways. Into number of groups is, that is number of group is m plus n factorial upon m factorial into n factorial. So this is the second corollary. Okay, first corollary, yeah, we can say. Okay, suppose if I'll ask you, suppose you have total m plus n plus p objects. Okay, and if I'll ask you to divide these m plus n plus p objects into 3 different groups of size m, size n, size p. Okay, so what is the number of ways to divide with 3 groups of size m, n, m, p respectively? What is the answer? That is actually the simplest way. First, m plus n plus p. Out of these objects, we need to first select m, and then we are left with n plus p, c, n. Okay, then p, c, p, and this is equal to actually m plus n plus p factorial divided by m factorial into n factorial into p factorial. This is your answer. Okay, when you are distributing, what you are doing? You are multiplying the number of groups with the number of ways of division of groups, right? That is 2 factorial. When you are finding, or when you are dividing into groups of size, different size of groups, then that is the answer for this. Okay. Okay. Next is, now we'll see corollary 3, the number of ways to distribute. Same thing. If I'll ask you to total number of objects is m plus n plus p, and you need to distribute these objects among 3 persons. Among 3 persons, group containing m, n, p. You need to distribute here in case of distribution among 3 persons. So what is the answer? That will be क्या हो जाएगा? That is number of divisions, number of ways of divisions of groups, that is 3 factorial into number of groups, that is m plus n plus p factorial divided by m factorial into n factorial into p factorial. This is your answer. ठीक है? Okay, clear? So in generally we can say, if you have n number of objects, suppose we have n number of objects x1, x2 plus up to xn, then we can divide these into n groups, okay, of size x1, x2 up to xn. Okay, then the answer will be, the number of groups will be x1 plus x2 up to xn factorial divided by x1 factorial into x2 factorial up to xn factorial. This is the answer, right? Okay. Okay. Next, in the next class, what is the time now? It's time to end here. So this is the division of groups, and we'll start from this topic also. We are left with some other properties of division of groups, and we'll solve some question in the next class also. And one more thing is, guys, one more thing is, just a minute. Yes, yeah. Okay. So what we have covered in this class, guys. So the important thing is circular permutation. This is from this topic concept also. Circular permutation, from this concept questions are coming in JMail, right? So when the anti-clockwise and clockwise are not equal, we are not considering anti-clockwise and clockwise cases are equal, then the total number of arrangement in a circle is at 3 persons, A, B, C, and we need to arrange them in a circular table. Then this will be, suppose here, yes, then we Akola in the in next class we'll solve some questions. We'll basically solve some questions. Okay, don't worry. Okay, next class we'll solve questions because we don't have time now. Just I am revising the concept here. You can see here. This will be for this place. C can become here C A B. One more is B C A, and another one is okay A B C C A B B A C. That is the number of total number of ways. What is the total number of ways here we are getting? Sorry, already we have solved this one. Okay, we are starting from E. A. Okay, so okay, that is the total number of ways will be n minus 1 factorial. Na? Yes. So in this case, actually what happening, n minus 1 factorial. The number of ways. I will take some more details in next class also, how we can understand this concept very clearly. And when we are considering anti-clockwise and clockwise directions, when we are counting anti-clockwise and clockwise directions are same, like in case of garland or bracelets, in that case, we need to consider those two cases as one. That's why we are counting twice. That's why we are dividing n minus 1 factorial by 2. This is the formula for when anti-clockwise is equal to clockwise. Okay? But in case of when anti-clockwise and clockwise directions are not same, different, so the answer will be n minus 1 factorial. This is simple. Okay. Thank you all. This is the time. This is time to end the class here. So thanks all. Thanks for your time. Thanks for your